Yeah, story problems. Is that what we were putting them under?
Yeah.
Sorry. Story problems. I believe so far, children, we have talked about combining and separating, right? Have we done combining one, separating one? So there's your addition, subtraction. Today we talked about equal groups. If you were guessing what story problems about equal groups would actually be about, Nathan, you would say?
Dividing?
Yes, and multiplying, both. Okay, because if I said there are 25, sixth graders, and I divided them into 5 equal groups, there's your division part right there. But here is the pattern, and again, the pattern stuff nobody likes to do because it gets a little wordy and whatever, but this is the pattern that you will see in an equal group problem. It is this, and you'll enjoy it to no end. It's just so much fun. The number in each group, I think I remember doing this last year. The number in each group times the number of groups always will give you the total in all groups. That is your pattern. That is what we can abbreviate it to be number in group times number of groups equals total. Now I can tell you're just as anxious as can be as to see how this actually applies to real life. Yes? Yes. So here, let's write down this problem. There were 232 sixth graders in 8 classrooms. There were 200, what did I say?
36.
236?
232.
232? I said 232. 232 sixth graders in each classroom. Oh wait, no. In what? Help me out here, people. Don't leave me in 8 classrooms, right? In 8 classrooms or 6 classrooms? What did I say?
In 8.
Did I? In 8 classrooms. It's been a long day, by the way. In 8 classrooms. What do you think they're going to ask you? How many will be in each classroom?
I wouldn't have never guessed that.
Who's that? What's that, Sam? How many in each classroom? And again, I know right off the bat, you're saying, man, I know how to do this. Why is that insane math teacher going to try to explain it to something that's just going to confuse the bejeebies out of me? Oh well, just the way it goes here. The problem with the whole grouping thing is not always in math do they say the word groups, so you have to figure out what word in our story problem stands for a group of something. And you being the intelligent and very English-minded sixth graders, having Miss Shum as your English teacher, you know here are the nouns. We got sixth graders, I believe is a noun. We've got classrooms. I guess that's all we got. How many? I guess many would be how many sixth graders in each classroom. Is a sixth grader a group of something, or is a classroom a group of something?
Sixth graders.
Sixth graders a group of what?
People.
No, a sixth grader, not sixth grade. You are singular, are a sixth grader. Sixth grader is not the group there. Now, sixth grade class would be, but this is your word for group. What is a classroom?
A group.
A group of students. Are you not all in this classroom? So, changing the verbiage on this would be this. Number in each classroom. Number in each classroom times the number of classrooms you as a sixth grader are not a group of anything. I guess you'd be a group of cells. If you're gonna do that. Equals total sixth graders. And then, if you were filling in the blanks, do I know how many classrooms? Do I know how many are in each classroom? Or do I know the total? Which of those do I know? How many are in each classroom? I don't know. That's my N. How many classrooms do I have? 8. And then how many total sixth graders do I have?
232.
232. So it's a multiplication pattern problem, but as you will say, anytime we have a missing number problem, we always think of an easier problem. In this case it is, going, let's do 3 times 8 is 24. If I don't know the top here, what do I do with these two to get the top? What do I do with 8 and 24 to get 3? I divide them, so in this case I'm also going to divide 232 divided by 8 is, gosh, I hope this works out. 2 is what, 16? 72, oh yeah. 29 is my letter N, which is how many would be in each classroom. Which is close, you guys have 25. And again, I understand you don't have to do that to do the problem, but this is 6th grade math, and as Sammy will attest, how many more years of math, Sammy, do you suppose you're going to have to take in your life, not to be a downer? Well, I believe you're in 6th grade. To get out of high school, I believe you have to take a year of math all the way through to the end of high school, so that's at least
college.
6. Well, college, it all depends on what you're going into, but most areas need you at least to take 2 years of math, so now you're at 8 years of math, and a lot of them, if you're doing engineering or anything, nursing, all that is so much math that you have to take 4 years of math. So you've only got 10 years of math. And this is 6th grade math. The point being, math gets really hard. And that's why the book tries to teach you to think in terms of like this, because not always will it be super clear to you what you'll do. But if you can do the easy stuff following the pattern, you can do the hard stuff following the pattern. That was great, wasn't it? One last problem. One more, just because I like the colorfulness of all this. Let's go with black again. In the parking lot, there were 18 parking spaces in each row. The parking lot had 18 spaces in each row. Poof. 18 spaces in each row. There were 12 rows of parking spaces. This is too easy. 12 rows of parking spaces. And the question is, what is for lunch?
What?
Oh wait, no, that's not. The question is,
Pizza.
What is for lunch? Pizza!
how many parking spaces are there?
How do you get that?
If we set this up according to our little pattern problem, you have to figure out what is a group. What is a group of something? So looking at the nouns here, well, we've got a parking lot, we've got spaces, and we have rows. One of them is a group of something, and you may get confused on part of this, but let's see if we can figure out. What is a group of what? What is the word, instead of the word group, what word is there? Victoria?
Row.
Row is a group of what?
Spaces.
Yep, it is. The parking lot obviously has a lot of stuff in it, but it's not, you don't even need parking lot in there. You could just say 18 spaces are in each row, there are 12 rows. Parking lot is just kind of what it is. So if you fill it into this thing, the number in each row times the number of rows gives you total. And this one's way too easy because they tell us both what? How many rows and how many are in each row. we don't really have too much to think about. How many are in each row? 18. How many rows? So what I don't know is the final answer, which is pretty simple because it's just a multiplication problem. What's that? 216 parking spaces total. I thought that was exciting.